cat interviews at Uber, Confluent, Indeed, and many more companies. I've seen it all. After countless hours on the other side of the table, I know exactly what top companies are looking for, especially in LLD. In this course, I'll share the insider blueprints, what to focus on, especially key design patterns, how much multi-threading, very important, counter question, traps, and how to tackle them confidently. This course is structured, practical, and tailored on what companies are looking for right now. Let's get you interview ready right now. Next, we move on towards the visitor design pattern. Now, this visitor design pattern, the word itself says visitor. So imagine that you are in a hospital where different kind of patients are there. It can be child, adult, so on and so forth. And obviously, there will be a visitor which will come and visit you. Now, when I say come and visit you, it doesn't necessarily mean that you cannot go to them. Obviously, you can also go to them. So imagine the staff. So staff can be a doctor, it can be a nurse, it can be a billing person, it can be massaging person, and so on and so forth. So obviously they will come for checkups, treatments, so on and so forth. So basically our staff, again, whenever I refer doctor here, I'm referring staff. They can perform different operations. Obviously diagnosis, maybe nurse can do it. Billing, the billing staff will do it. And obviously so on and so forth. Your operation will do by actual surgeon and so on and so forth. Now, what can happen or what can go wrong? Basically, if every patient will handle all these operations, then it will be very cumbersome. And in that case, we use your visitor design pattern. What I mean by that is, obviously, we have three patients, let's say child, adult, senior. Now, again, I can have more types of patient as well, but in general, if we want to classify, we can classify as a couple of patients. But the operations which will be done will be diagnosis, billing, massage, operations, surgery, and so on and so forth. Operations can be literally many. Now, in a normal traditional approach, what will happen that a child patient will be diagnosed, will have its own corresponding billing. Same way, an adult patient will be diagnosed, will have its own corresponding billing. Same way, a senior patient will be diagnosed, will have its own corresponding billing. Now, firstly, did you see one very basic issue which I did? First, okay, I'll tell you first issue. First issue is that there is no patient interface. So technically, I should have a patient interface. And again, these may be an abstract class, depending upon whatever you want in your existing class. If you will have that, then you should actually implement those. You can have a patient interface, and that's where it all these should implement. Why this is required, you will see as I will show on the issues to you. But another next issue which we can easily see is, as I mentioned, there will be a hell lot of stuff, hell lot of operations which can happen in a hospital. As I mentioned, diagnosis, billing, surgery, massage, and so on and so forth. Now, if you end up having all of them inside the patient, all of them inside adult patient, all of them inside senior patient, then what if in future something changes, something diagnosis needs to be changed for, let's say, a child patient, then unnecessary the child patient class will be disturbed, and that's an issue. So first issue, we saw that we should make sure that we can have an interface, and that will actually make our problems much more easier, and I'll show you the problems as well. But second thing, we saw that anytime I add any new visitor, any new visitor, if I add, let's say for massage or let's say for surgery, then firstly every of these patient classes will be impacted. Secondly, if I have to change any existing thing also, then again unnecessarily my patient class will be impacted, and again it will become bloated as well, because obviously billing will involve many steps which technically will unnecessarily bloat patient, because it's an operation of billing, so it should be in a billing, not linked to patient. So that's the issue which we figured out, that okay, obviously the thing can become very complex. Now, starting off with the first issue, as I mentioned, that if I will not have any parent, I don't have any interface, obviously whenever I make any patient, I will have to assign it to an object, and then before I even call diagnosis or billing, I will have to check if it's of patient, if it's of if it's a child patient, if it's an adult patient, if it's a senior patient. So obviously some if else which made the code very bad. Again, that's not what the essence of your visitor pattern is, but still you see that the code has become bad. And like, again, obviously you can have multiple stuff happening, but the entire essence is that the code has already become bad. So firstly you will have an interface to it. Secondly, even if you have an interface, then for every patient, having a hell lot of operations to it doesn't make sense, right? It is very tightly coupled. And if you do any change in billing, you will have to touch this patient firstly. If you want to add any new visitor as well, and when I say visitor, it can be any staff. Let's say now I am having a cleaning staff also. So cleaning will actually link, or maybe there is a special staff for, let's say, senior patient, or for all the patient there is a staff, but let's say all of them will have a special functionality for senior patient. So obviously again I will unnecessarily have to change the operations for that senior patient and all that. So again, unnecessarily touching the corresponding wrong file. So we saw the issues, and that's the main concern, that if we have a lot of operations here, it will be very hard. And that's where the visitor pattern comes in. So let's firstly correct the existing patient class. I will have a patient interface. He will simply accept what? Accept a visitor, which means that inside my patient, inside my child patient, inside my adult patient, inside my senior citizen patient, I will not have operations, which can happen in a hospital. No, which means you can have different kind of visitor. It can be your diagnostic visitor, billing visitor, reporting visitor. As I showed, it can literally have many. So every staff you can imagine it as a visitor for you, because obviously if you are in a room, then your billing person will come to ask money. Again, imagining it's a 5-star person, like you don't have to go to counter. I know that you have had to go into counter, but yeah, your nurse will come, doctor will come to you, so everyone is a visitor to you. And again, you are kind of patient right now here. So you see that we don't want to have everything inside my child patient. So I'm just kind of removing all this from the child patient and keeping it separately, and say, okay, this will be a visitor, and the visitor will come to your any patient, and thus I will accept a visitor rather than accepting any specific thing. So if I go back and I show you, earlier I was having that specific diagnosis visitor, billing visitor inside it, and I was kind of hard coding it. And that's what I will not do. I will decouple things just to make it more scalable. Let's see how I will do it. So firstly, as I made the interface, I will just make sure that my corresponding child patient will implement the interface, and adult patient same, and senior patient same. They all are doing the same thing, that whatever visitor is being asked, so the visitor will simply visit the current object. Visitor will simply visit the current object. Visitor will visit the current object. Now comes the most fun part, the visitor. Now, the visitor, technically, again, as I mentioned, you might say, Aryan, it might actually, the visitor might unnecessarily have to implement, like whoever is the actual visitor might unnecessarily have to implement all of these stuff, which means the your adult, child, and senior patient. But again, that's totally a functional choice, a business use case, that if you feel like that all the visitors should not implement all the patients, then you can handle it separately as well. You can make multiple hierarchy of how your implementation should look like, and that's how you can handle it. But here in this case, we are imagining, because the patient is a key entity here, and everyone revolve around the patient. Every service in the hospital revolves around the patient, so everyone will indirectly directly interact with the patient. So it's the reason a visitor will literally interact with every possible patient which we have, and we have only 3 possible patients in my hospital: child, adult, or senior. Now let's come on to the first visitor who will diagnose you. Again, you can imagine it as a nurse visitor. So a nurse visitor will, as we saw earlier, so you know that every visitor will have that visit function which will accept the current patient. So my visitor, which is in this case my diagnostic visitor, which is the nurse, it will have a visit function which will accept the object, which is my child patient, or a adult patient, or a senior patient. And again, as we saw, that everyone have to implement this, everyone have to get all of them. So with that, now for nurse visitor, for a child, she will have its own implementation. For adult, she will have its own implementation. For a senior, she will have its own implementation. And again, that can be a very cumbersome implementation. But now, the best part is that entire thing is now with the nurse visitor. And in future also, if I have any different visitor, everyone will actually implement their own logic and will be separate from whatever visitor I have. For example, I have billing visitor. So they will have their own, because the child will require lesser money, adult will require, more money, senior very high money. So again, the entire logic of billing, all that stuff will be separate here and will be inside my billing visitor. And that's how you see that anytime in future I have any other functionality in my hospital. Let's say I become a premium hospital. So now I am a premium hospital. So in my premium hospital, I will have a premium visitor, or I should say a premium functionality visitor. So I have a person, I have an assistant for you, which will keep on checking you. And that's a premium functionality which I incremented. So basically I got the money, funding and all that stuff. So I made my premium visitor. So that premium visitor, which is your kind of, personal assistant visitor, that can also handle everything, everyone. And again, to incorporate your new visitor in your office or in your hospital, you don't have to touch any existing piece of code. No, just make a new class, implement the existing visitor interface, and then override the corresponding each individual visit method, right? And that's how you can easily incorporate any new visitor. Again, let's see how as a main function it will run. So imagine I have these patients. So I have a child patient, adult, and a senior. And again, right now in my code, I have, let's say, two visitors, diagnosis visitor and a billing visitor. So I'll simply iterate on the patients, and I will simply call that patient will accept a diagnosis visitor, which we saw above. Patient will accept a billing visitor. Now, as we call the accept function, if you remember, the accept will go up, right? Accept will go up, and accept will say that patient accepts the visitor. So visitor go and call the visit on that current patient. So if my child patient went ahead and called the accept with the diagnosis visitor, so I'll go on to now diagnosis and call the visit and call the visit method with the current patient as the child patient. So I'll go on to the diagnosis, call the visit method with the child patient as the current object, and then I can simply print this. This time I can simply print it. And again, because the logic can be very cumbersome, but it will still linked to the diagnosis visitor logic, because obviously diagnosis visitor is the one who should change his logic when he is visiting a child. Not a child should keep a logic of diagnosis visitor. And that's the entire decoupling logic which we have done. And as we saw that we will have corresponding patient, and again we have different type of patient: child, adult, senior. Again, these patients will be limited, you because obviously as again it, even if it extends, you simply will still have to change it in your individual classes. Now you might say, Aryan, isn't it very cumbersome to change all the classes? It might be and it might not be, depending upon the business logic. You can incorporate other design patterns as well, just to make it more modular. But the high level idea is that if you incorporate and your business grows a lot larger, then if you have a new personal assistant, or let's say AI visitor, let's incorporate AI as well. So if you have an AI visitor, that will cater your each individual patient, which is child, adult, senior, with their own corresponding logic. And that's the reason we just took it different implementation. If you want that, okay, implementation should be same, you can also abstract with a different abstract class as well. There are multiple ways to go about it and make it more modular, or you can say more in a decoupled manner. Because you might say, Aryan, maybe in future if I have to change the implementation of child visitor, then I will have to change everywhere. It is true, but obviously if you think of very closely, it should be independent as well, because diagnosis for a child is different than a billing for a child. It is different from health for a child. So each and all should have their own corresponding implementation, and that is the reason we have kept it separate, so that everyone can actually implement their own, right? Again, so that's how it will simply work. Now, the catch is, if we have any new visitor in the future, as we saw that we can have a AI visitor, or a personal assistant visitor, maybe a health report visitor, which will keep on telling you health. Obviously, it will simply go and implement your visit method. And again, never touching it. It did not touch any of your other classes. It did not touch your patient. It did not have a touch on any of the childs, or any of the other implementation, or concrete classes of patient. It only has a new implementation here and not touching any of the existing code. And that's the beauty. So that's how the beauty will work. Now, obviously, the benefits here will be separation of concern, because now the things which want to touch are touching, and which does not are mostly not touching each other. And any new addition of operation is very, very, very easy. There is a double dispatch logic. What does that say? It says that execution, like the executed operation depends upon the type of visitor which we have, which is literally can be a lot, and the patient. So now the logic is primarily decoupled. So for a diagnosis child, we have some logic. For a billing child, we have some logic. For health report child, we have some logic. Diagnosis senior, we have some logic. So that's how the entire execution operation is dependent upon both these things. Now, obviously, the things are much more simpler and cleaner now, because now there will be no bloating in one specific class, and unnecessary bloating in child when he has to handle all the operations of a hospital, which obviously does not make sense. And now we have more flexibility in operation as well, because we can change how the billing works. And again, that too for an individual patient I can change, because if I think, okay, right now the actual teens are drinking a lot. Let's say if the data says, okay, they are drinking a lot, then I can say for the billing for teens, or the billing for, let's say, teens, I will give an extra 1% charge. And that I will only have to change in the billing for my this teen, or I should say adult, as the impact or the function which we have. And that's how you can simply incorporate any new change onto a specific patient. And again, some of the real life use cases can be shopping carts. And you might say, Aryan, how shopping carts? See, any item which you have, let's say book, electronics, groceries, they can be visited by different stuff. Now, you might say, Aryan, visited by customers? No. Visited by discounts, shipping cost, taxation cost, all that stuff. So again, visiting something depends upon, see, why I took the example of hospital, because it's very easy to see. Patients are being visited by hospitals, nurse, doctors, all that stuff. But in real life, it's very hard to understand that how your books, electronics, groceries can be visited by multiple of these stuff. Discounts, shipping cost, taxation cost, all that stuff. Same way, file system, it can be visited by virus scanning, file compression. So you see that, imagine the file system as any file as from the patient, and then virus will come up and check, okay, are you okay? They will run their diagnosis on you. Same way, file compression will come and run something on you. Same way, so any calculation logic will come and run something on you. So people are coming and visiting you. That is your visitor design pattern. And again, they can be multiple things. It can be UI components, tax system calculation, and so on and so forth. Now, to wrap up, as we saw that we have staff as in doctors, diagnostic person, billing person, all that. They simply go and visit the patient and perform their corresponding operation. Operation for the staff will be diagnosis, billing, and so on and so forth. And this will never overload the patient with extra code, because now patient is entirely decoupled and it does not hold the logic of what the hospital should do. And with that, it makes things much more cleaner, easier to maintain, and extremely flexible. And that's the beauty of your visitor design pattern. Now, with that said, as I mentioned, the entire course is structured such that the most important ones are at the top. And with that, you will see that strategy, observer, iterator, and command, and again a bit of state as well, are primarily, or you, if you want, even now I'd say primarily these three are used, not the other ones. So even if you feel like, you should be good with considering, even if you cover the starting ones. But as I said, our duty is to cover all of them, and we have covered this one as well. But with that, this is entirely on the basis of preference, that these are very highly used, others are not. Same way is for creation as well. These are very highly used, these are very highly used, prototype is not. So that's, with that said, make sure that we hit the like target of 250 likes, and see you next video. Goodbye, take care, bye bye.